Hi guys, let's look at one more example for momentum conservation. And in this case, it's going to be an inelastic collision, and it's going to be in 2 dimensions. So everything that we've looked at so far has been one-dimensional, and I wanted to make sure to show you a 2D problem so you can see how to work in the components, how to look at the fact that you need to look in both x and y when solving a problem like this. Okay, so the question. Billiard ball A of mass 0.130 kilograms, moving with a speed of 2.95 meters per second, strikes ball B, initially at rest, of mass 0.135 kilograms. And as a result of the inelastic collision, ball A is deflected off at an angle of 29.5 degrees with a speed 2.4 meters per second. Find the speed and direction of ball B. Okay, so what we're working with here, come on, pen. We have, let's give ourselves a coordinate system. We have ball A. Mass A is 0.13 kilograms, and its velocity 2.95 meters per second. And so this guy is moving, and it's going to hit mass ball B of mass 0.135 kilograms. And as a result of this, let me try and draw this as neatly as possible. So mass A is going to be deflected off at an angle of 29.5 degrees, and it's going to have a speed. So this will be VA prime. That is 2.4 meters per second. And we know that let's call this theta B. We know that mass B is going to be deflected down because the sum of the momentum in y is going to have to be conserved. So if the one goes up, the other one is going to have to go down. But we don't know the exact angle, and we don't know the exact magnitude, i.e. the speed of ball B. And we're going to use momentum conservation to figure it out. Okay, so we have a couple other things to note. This is going to be an inelastic collision. So as a consequence of that, we know that we are only going to conserve momentum. Energy is not going to be conserved. We have our various masses and speeds and everything. So let's look at momentum conservation. So we know that both the sum of the momentum in x and the sum of momentum in y are going to be conserved. So let's set up our equations. So if we look at the sum of the momentum in x is going to have to equal the sum of the momentum final in x. And what does that look like? Well, we have MA VA. There is no MB VB, but that will have to equal, because the VB is 0. So that's going to have to equal MA VA prime, but we only want the x component. So you can see from here, the x component will be cosine theta component. Let me be really explicit. I'll call these angles theta A and theta B as well. So this would be times a factor of cosine theta A. And then we would also have the contribution from ball B, MB VB prime cosine theta B. Okay. So that's our sum of momentum in X. We also would have, and let's call this, equation 1. We also have the sum of momentum in Y. So the momentum in the Y direction, initial, is going to have to equal the momentum in Y final. So what equation will that give us? Well, notice there is no momentum in Y initial, so this is 0. And this will equal MA VA prime times the Y component, so this will be sine theta A, plus MB VB prime, the Y component would be sine theta B. Now, I want to be careful here. We can tell from our picture, and just to emphasize, it's always good to have a picture, right? So it helps us straighten out things like directions, for example. We can tell from our picture that this quantity is going to have to be negative. And we can see that from the math, too. This thing is going to be negative. So in order for that to be negative, with how I have it drawn now, it means that we are expecting a negative angle. And that's fine. Alternatively, you could instead put a negative sign here, and then you would know that this angle would be positive in that, with that, setting it up that way. The main thing is just to be consistent. So I am going to have this be a plus sign here, and we'll expect a negative angle. So we can follow up on that as we work through the math. But I just wanted to draw your attention to that. Working with vectors, we have to be careful about the directions and the components. And so since these things are going in opposite directions, we know that they're going to have opposite sign. So it's good to be careful about the angle. Okay, so we have two equations, two unknowns, both angle and the speed. So we need to figure out some way to eliminate one of our variables. So there's different ways that we could go about this. This is not a unique solution, but I'll show you one way. So let's take from our first equation and substitute and come up with an expression for VB prime, and then put that into our second expression. So in other words, from 1, so we have two equations here. From 1, let's solve for VB prime. So VB prime would equal MA VA minus MA VA prime cosine theta A, and then we would have to divide by MB cosine theta B. Okay, so now we have an expression for VB prime. And then let's take that expression and substitute it into our second equation. So our second equation, let's see here, we can subtract in one direction. So we'll have MA VA prime sine theta A equals negative MB. Now VB prime is this thing, MA VA prime cosine theta A divided by MB cosine theta B times, don't forget our factor of sine theta B. So now we have an expression that doesn't contain VB prime. And then let's try and consolidate this here. So notice this sine theta b divided by cosine theta b would be a factor of tangent. And actually, we have some other stuff that we can simplify as well. So let me change color here just to... So we have a factor of mb over mb, so that would cancel. We have actually a factor of ma that appears in every term. So that would cancel as well. Okay. And this sine over cosine would also give us a tangent. So here, let's rewrite after we've eliminated those factors. So we would have VA prime sine theta A equals negative tangent theta B times VA minus VA prime cosine theta A. Okay, so a much more concise expression. And remember, what are we looking for? We're trying to find the direction and speed of ball B, so we want to solve this expression for theta B. So if we divide by this, then we'll have theta B on one side. So let's do that. Tangent theta B would then equal negative VA prime sine theta A divided by this thing, VA prime cosine theta A. So now we have an expression for tangent that's in terms of all the stuff that we know. The initial velocity of A, the velocity of A after the collision, and the angle of A after the collision. So of course, if we wanted tangent, then we would have to take an inverse tangent of that. Inverse tangent of this, this thing. Okay, so let's put in our numbers here. There's tangent of 2.4 times sine of 29.5 degrees divided by 2.95 minus 4 cosine of 29.5. And if we evaluate that, we find that theta b equals negative 53.9 degrees. So we found theta b, and our math has shown that it's negative, as we expect. It's got to be below the x-axis. So this is consistent with our picture from above here. So the only other ingredient that we need is the velocity. So we have theta. What's VB? Well, we can get that from our substitution above. So this is going to equal, so let me write it in and then we'll give ourselves some room. So VB prime is MAVA minus MAVA prime cosine theta A divided by MB cosine theta B. Okay. And we can put in our numbers. And if we were to do that, so now that we know, theta B from here, and we know theta A, etc., we could put all these ingredients together. And we would find that VB prime equals 1.4 meters per second after you put in your values. And this is a good example of a problem. It shows you how to approach things in 2 dimensions. You're going to start with equations for both the x and the y components of momentum because you have to conserve them both. And in this question, this allowed us to come up with 2 equations, and we had 2 unknowns, a velocity and an angle, and we were able to do some algebra to solve it. This is by no means, the only way to solve this question. We could have substituted differently or eliminated one of our unknowns differently, but it should give you an idea of how to approach these kinds of problems. So hopefully this helps you with your homework.